Okay, so thank you all for coming. I'm Steffi Baum. I'm the Dean of the Faculty of Science. That's what it says here, so that's how I know, at the University of Manitoba. And I'm really happy. This is our, how many times have we done this? Third? Who can remember? Three? Fourth. Oh gosh, fourth. Thank you. Annual Honored Alumni for Science event where each of the departments nominates an individual to be their honored alumni for the year. And they come in and then they're with the departments and they do all sorts of exciting things with the students and give talks and interact with you. And then they come here and they share their wisdom with us, and you guys ask them questions that elicits some of that exciting advice that they will give you. So I'm really pleased that we're all here today. I'd like to start by saying that the University of Manitoba campuses are located on the original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. So again, as I said, we're really excited to have them. These are some of our sterling examples of what a undergraduate or graduate education here in Manitoba in science will lead you to. And if past experience is predictor of today, we will hear some really interesting pathways to their success that will be very, very stimulating to us all. So I think I will start by introducing our panel of distinguished guests. And I think these are in random order, so please wave in your hand or stand up or something and say hi when I introduce you. Allyson Hindle received her BSc honors in 00, her Master's of Science in 02, and her Ph.D. in 07 from the University of Manitoba. She was a comparative animal physiologist at Harvard Medical School, and she is now an assistant professor at the University of Nevada. Dr. Hindle has simulated floods in astronaut training and tracked 350-kilogram Weddell seals in the Antarctic. Dr. Albert Friesen received a Bachelor of Science with honors in 69, a Master's in 71, and a PhD in 81 from the University of Manitoba. He is CEO of Medicure Incorporated, president of Genesis Venture Incorporated, and founder of Biotech Canada, general partner of Centerstone Ventures. Considered a founding father of the biotechnology industry in Manitoba, he has consistently driven and fostered research into new drugs and innovative therapeutic strategies. Many of his discoveries have saved lives and improved the quality of life for people afflicted with disease. Christopher Batty. Dr. Batty received his Bachelor of Honors in Computer Science from the University of Manitoba in 2004. He's an assistant professor at the David R. Cheriton School of Computer Science at the University of Waterloo, a rising star in the area of computer graphics, and his research has been acknowledged for its excellence by both the academic and industry communities. Dr. Batty's work has been integrated into some of the most widely used computer graphics software packages, and his special effects have been featured in numerous mainstream movies. Now there's a question for you guys. Dr. Prashin Chalikani? Is that right? Okay, good. Received his PhD in microbiology from the University of Manitoba in 2004. He's a professor in the Department of Oral Biology at the University of Manitoba, a scientist at the Children's Hospital Research Institute of Manitoba, and the director of the Manitoba Chemosensory Biology Group. His research focuses on taste receptors and on trying to understand the bitter taste signal transduction in humans. He has made significant inroads into different disciplines, including nutritional sciences, physiology, microbiology, biochemistry, and pharmacology. In 2015, he established the Manitoba Chemosensory Biology Research Group, which brings together researchers in Manitoba with common interests in studying human chemical senses. Dr. Shirley Mills received her BSc Honors 69, Master's 70, and Certificate of Education 71 from the University of Manitoba. She is an associate professor of mathematics and statistics at the School of Mathematics and Statistics and Faculty of Science, Carleton University. She is also the graduate co-op advisor at Carleton University and executive director of the Statistical Society of Canada. Dr. Mills is an expert in analysis of complex, massive data sets. She developed the first Canadian graduate university course in statistical data mining over 20 years ago. We're a little behind here, huh? Dr. Mills' contributions to teaching and research into applied statistics, mathematics, and computing are extensive. Jeff Martin received his BSc honors in '95 in physics from the University of Manitoba. He is currently a Tier 1 CRC in fundamental symmetries and subatomic physics at the University of Winnipeg. Dr. Martin is the Canadian leader of a major experiment searching for the neutron's electric dipole moment, which is being conducted at TRIUMPH. A joint effort between physicists in Canada and Japan, it seeks to search for additional sources of CP violation that are required, for example, to explain the predominance of matter over antimatter in the universe. So that's our suite for today, and unfortunately, the mathematics honored faculty member was unable to come, so mathematicians will have to listen to statisticians and physicists and chemists. So let me start off with a question to get them going, and then that each of them will answer, and then we'll take questions from the floor, which can either be directed at an individual or multiple people may end up answering. So the first question, which was, I think, provided by one of the students, was there an event that motivated you to pursue a career in science? How did you end up as a scientist? You can start. We'll go down the line. Okay. We have to talk into the, yeah.
Okay, I'm not supposed to be sitting here. I'm the only person in my family that went to university, and this is the entire family. I was not supposed to go to university. I was pressured to become a secretary. I ended up at the top of the students in the entire province, and I did not know there was such a thing as a university until grade 12. That's the background I came from. I came out here because I wanted a scholarship. And I convinced my parents actually to allow me to go to what is now the University of Winnipeg, but in 1965 when I started, it was United College and it was a part of University of Manitoba. I won a scholarship at the end of that year too. Only problem was they told me I was really good in math and I should do honors, and I couldn't do it there. I had to come out to what is known as, that time, the farm. So at that time also the University of Winnipeg became its own university. It was United College, became its own university, so the scholarship that I won was not transferable to the University of Manitoba anymore. And I came out here and I met up with somebody called Dr. Ernie Vole. I don't know if any of you remember that individual, but he was an actuarial professor. And I was asking, I was in math, physics honors, because I didn't know anything else. And I had one opening in my program, an elective. I asked Dr. Ernie Vole in August what he suggested I might take. And he said, hey, you're good in math, take a stats course. I had no idea what statistics was. And then he said, well, you can go overload. Take an actuarial science course too, because he was an actuary. And the rest is history.
Well, I was an undergraduate here at the University of Manitoba when I decided that I wanted to be a scientist. And it was at the moment that I decided I did not want to be a doctor. And you know, I love medicine, and I realized that I loved learning about how the human body, how the human animal worked. And while I was taking my classes, planning to put my application together to go to medical school, I was here in the Department of Zoology, and I looked around and I realized that I was in this amazing environment taking courses that could launch me on a career to understanding how more than just the human animal worked, learning about how all different animals work in their different habitats and trying to understand a little bit more about how the world works. And so that was just doing projects and learning about things with my hands and taking classes really helped me realize that I wanted to keep going and I wanted to keep learning more.
Okay, so for me, as a kid, I had sort of vague ideas of what a scientist was, and I guess I'd sort of generally been interested in math and science. But I can't pinpoint a specific instant when I decided, okay, now I'm going to be a scientist. It was sort of a gradual evolution over the course of my life. I think as a middle school student, I discovered one of my friends was programming computer games in his spare time, and this struck me as the most magical and amazing thing that any 13-year-old could ever imagine, right? And so I started learning to program, and from that point on, I was sure I wanted to do computer programming of some kind, not necessarily be a scientist, but certainly pursue a career in computers in some form. And so from there, I continued through high school, went to university, just kind of followed a more or less standard path into computer science. And then through the co-op program here at Manitoba, I got the opportunity to intern at a local visual effects studio called Frantic Films. And there is where I first got the chance to start learning about physical simulation. So my background is computer science, but a lot of the work that I do is kind of essentially continuum mechanics for simulating different physical phenomena like fluids and gases and so forth. So that was where I was first exposed to that, and I was kind of doing it in industry feeling like, I don't know what the heck I'm doing. And so from there, I decided, okay, I'm going to go back to grad school, and I went to grad school out in Vancouver. And even there, I wasn't sure if I really wanted to continue on to become a scientist per se. I just was really excited about the stuff that I was learning. And I think, I don't know, the actual turning point, probably my girlfriend was like, well, you've come this far, why don't you just kind of keep going? I was like, okay, sounds good. Yeah, and that was, I guess second year of my master, or year and a half into my master's, I decided, okay, I'm going to stick it out with a PhD and see where that leads me. And here I am.
Oh, you can use that one and pass it back.
Oh, okay.
I fell in love with chemistry, believe it or not, in grade 11, chemistry teacher. And so as I finished grade 12, came to the University of Manitoba, registered in chemistry. After the first year, I did have some thoughts because it wasn't exactly what I was expecting. But I persevered, in fact, was encouraged to persevere by the department. So I went into honors chemistry in second year and did focused on chemistry only through 4 years. And got more and more interested, particularly in third and fourth year when I started to do biochemistry, the application of chemistry to understanding the structure of proteins. And did a master's degree doing that and started a PhD. But when I started the PhD, I was not convinced I wanted to pursue the academic route. I was more interested in the application. And coincidentally and totally unrelated, two pediatricians came to my lab where I was studying a PhD, and they were treating Rh disease babies for a disease which caused the loss of a lot of babies. 4% of 1,000 babies, 4 out of 1,000 babies died from Rh disease. And these pediatricians had been treating. Bruce Chown had read a publication about a new way of making an antibody which would prevent the disease. So he gave me the publication, said, would you be interested in this? And not knowing exactly what to do, I said, sure. I was 23. And I asked him two questions. One is, what's the future? Because there was no company, it was an idea. And he says, what you make of it? And secondly, I asked, which is I've told to many of my employees, future is what you make of it. The second question I asked, I wanted to finish my PhD and get the degree, and I asked him, would I be permitted, if I took this job as the first employee, to continue? And he not only said, you can, you must. And so he basically made me work from 71 to 75. We got the product developed and into clinical trials, and he said, okay, now you can go back and finish. but I had to work full-time and finish the PhD part-time. But I just loved the application of the chemistry to making a product which Windrow, which ultimately my wife was on the clinical trial. Our 3 kids took the drug, so it's been an incredible journey, the application of science to a product which really helps health.
As you can see, I'm from India, and I tried to get into medicine there, and I couldn't. So I was doing my bachelor's in biochemistry. That's where my interest used to lie. And then when I applied to a couple of universities in Canada for doing a master's, one is Edmonton, and because my brother was doing a PhD there at that time, and the other university was Manitoba. Got admission in both the places, but it's more of Peter Lowen's work, which I liked. So he took me for a master's initially, and once I started doing, he said, why don't you actually transfer to a PhD in the first year? I said, okay, fine. And I really liked the work I was doing, so it's not that. And so I was done within 3.5 years, my PhD, and at the same time, I got an offer from Govind Khorana at MIT. So I went with him, went to his lab, and from there, yeah, it's mentors, I think. Mentors matter a lot, and they set examples, I think, and then that's pretty much where I ended up.
Well, if I have to pinpoint the event that got me into science, it's a tough one, I think. But the way I came into it was I always thought I would be a computer scientist, probably like you. And I came to university with the plan, I'm gonna get a computer science degree and program computers for the rest of my life, and it's gonna be great. I finished my first year of university. I remember the hardest course that I took was physics. And I hated that course. It was so hard. Of course, now it's my job. What got me into physics was after that first year, I remember distinctly getting a letter in the mail from the physics department, and it said something like, we'll give you $50 if you will come into physics in second year honors physics. And I took it to my family and I said, should I do this or what? Is this some kind of scam or something? And so it's like spam or something maybe, I don't know nowadays. But I followed up on it, and I just, at that point I said, okay, well, I'll try it. I discussed it with my family, and they said, well, it's such a special thing, and if you have a talent for that and you're good at it, you should go for it and just try it. And so I went into second year university honors physics, hardest year of my life. It was so, every course physics was the way it used to be. It's not as much like that anymore. And so, it was hell, and I survived it. At the end of that year, I managed to get a job with Professor Shelley Page, working for the summer at TRIUMPH, Canada's National Laboratory for Particle and Nuclear Physics. And I just thought that place was great. And this is, wow, so many people doing all kinds of crazy things. And that's what really, those two events, I think, the weird letter in the mail and then getting that job at TRIUMPH were the turning point for me.
Okay, thank you. Now we know the secret to getting, I'm a physicist too, is to bribe them, getting people into physics. Okay, do we have a question from the floor for our, please? We just have to get started. There you go, thank you.
So, how would you say that the employment environment in sciences has changed over the last, say, couple of decades? And what sorts of skills are becoming more in demand lately?
So I'll repeat just because you didn't have the mic. So he asked, how do you think the environment working in science has changed over the years, and what skills are becoming in more demand? Is that right? Yeah. So whoever wants to start, go for it.
It's a game of chicken there. So I'm in computer science. I can't necessarily speak so much for other fields, but I think computer science has been, like when I first got into it, everyone felt like it was a really hot area, and whenever I tell people, oh, you're going to computer science, well, oh, you're going to be rich, you're going to make so much money. But that was not at all kind of the motivating factor. I think it sort of has ebbed and flowed. I think there was a period of time where computer science has kind of gone down and other fields were more in demand industrially. And then these days with the rise of machine learning and artificial intelligence and data science, obviously all of those really heavily intersect with computer science. So our enrollments are kind of through the roof, and there's a lot of demand in industry for those kinds of skills. I mean, on the other hand, I'm in academia, so I don't necessarily see so much what's going on in the quote-unquote real world, but that's my impression, certainly.
I'm going to add to that because I'm right in data mining and data science. It is hot. Anything about data and analyzing data, analyzing big data sets. I'm also at Carleton University. I'm the Faculty of Science co-op advisor, and I cannot keep up with the demand for individuals that have the ability to analyze data and to work with computers to do it. I've never seen anything like this. And I have to admit, I've been a professor for 48 years in 3 provinces. It's amazing. And for any students that are studying this, I envy you.
I'm in the healthcare industry, and our companies, we have about 100 employees here in Winnipeg, and about 40 of them are PhDs. And I would say 80 to 90% have a university degree of science or master's. And so there are a lot of opportunities. Some of them are in sales, but surprisingly, I'm more of a lab researcher. But I found there's a lot of PhDs that come and they just love the idea of interacting with customers and people. They're not all at the bench. So there's a variety: quality assurance, quality control, patenting. There's a variety of different jobs that you can apply your science. It really depends. We had a PhD chemist come from Europe recently, and she's very good credentials, and she wasn't quite sure what she wanted to do. And I said, the hardest job to fill for a healthcare is quality assurance or regulatory. And she says, I'd love that. And she's just blossomed. So really, it's the application of your science interest to a variety of different jobs. I think there are a lot of jobs.
I'll say, yeah, data science, yes. My PhD student just got a job in data science, and she's very, very happy with that. And yeah, in a big firm in Vancouver. And for physics, I know you're a physics student, so yeah, for physicists also, very good job opportunities in that. The thing I wanted to say was what hasn't changed over the years is that you still have to sell yourself. You still have to have a very polished CV and be ready to go in there and sell yourself, and really there's some kind of basic aggressiveness that you have to have when you want to go out into the workforce and get that first job, whatever it is, second job, whichever. And that's something I wish we could do more of. I'm a professor also, and I wish we could do more of that for our students, train them somehow to have that salesmanship and basic know-how of how to go out into that workforce and tackle problems.
Okay, anyone else want to answer, or should I get another question out of the crowd? Good, okay. I'm fishing again for questions. Yes. Oh, wait, can you get the mic?
Is this on? Yeah, there you go. Okay. So I'm curious on a question about ethics. So in a variety of disciplines, particularly you, Shirley, you're very timely in this area, especially with like all the Facebook scandals and data leaks and all that kind of stuff. One thing I note that that was never actually a conversation in my undergraduate program, but it seems like something that should be more discussed in graduate programs, especially at the PhD level when you're doing original research, is whether or not some research should be done and how it's used in the real world. Like when we're talking about data science and all the uses for data, there's also a plethora of misuses for data. But as far as I'm aware, I don't think there's an ethics course at the graduate level that just talks about research and what you should and shouldn't do, like how to become an ethical researcher, not just like in terms of like copyright and like giving credit where credit's due, but whether if you're given an opportunity or you think of an idea that you could proceed with, whether or not you should do that. So I'm just wondering if you have any experience from different universities around the world, if that is something that's taught at other institutions, because I'm just not sure, and if so or if not, if it's something that should be talked about more generally, because I don't see it be talked about at all.
I'm going to answer that by saying, as a statistician, we have, I'm wearing a hat now as Executive Director of the Statistical Society of Canada, we have a code of practice. So that is an ethical guideline that we follow. When I'm teaching my students, and I'm teaching fourth-year honors and graduate students, masters and PhDs in this field of data mining, I'm showing them techniques that are extremely powerful, extremely useful. They can be used for good. They can be used for evil. They need to be aware of it. And I'm trying to instill in the students, an ethical practice. I think there should be a course in it. I think every area should have something like this. And data privacy is an enormous need. And frankly, I think all of you are giving away too much information about yourselves without you realizing at times. I'll go into my first lecture and I'll ask students, how many emails do you have? Does anybody have 2? Email addresses, yeah. How many have 2 accounts for email? Just 2. How many have 3? Anybody got 4? You all got cell phones? You're texting each other? You're tweeting? Hello. All of that information can be pulled together and analyzed, and is analyzed. And I make my students aware of what is possible, and hopefully that they understand that they should have limits too.
Anyone else? I think it's a more general question. Anybody else? Please.
Well, I'll say, yeah, I mean, I think, yes, scientists could profit from a course like that, and we should really consider it. And there's been many cases over the history of new technology coming along, and I'm a nuclear physicist, okay, and yeah, we don't have a great track record in that either, and you don't want to, it's not that way anymore, but it's, but yeah, if ethics had been a part of it, maybe things would be different.
I'll say something briefly. Yeah, so this is certainly something that concerns me as a computer scientist because, I mean, so much of this is a result of our data being online on the internet and connected all the time. In my specific area of research in computer graphics, what's particularly troubling is the way this technology is being used or has the potential to be used in like the political arena with the quote unquote fake news and all this kind of stuff. It's unnerving the degree to which we can fabricate plausible depictions of reality. And personally, I'm very concerned with how that's going to go in the next, 5 years. Like what we can do right now is already amazing, and it's only going to get easier as time goes on. So I mean, I certainly agree this is something we need to sort of integrate into our curriculum. I know that Manitoba had a CS ethics course, maybe they still do, when I was here, but I don't think it was required at the time, and I certainly didn't take it. I was very focused on the technical side, and it's one of these things you don't necessarily think about all the ramifications of what you're learning. So it is important to start thinking more and more as computer scientists about that. It's required for co-op? It's required for everyone. Great, I'm glad to hear that.
So I would support the idea of teaching ethics, but I think it's, when you ask the question, it's a broader question. I think leaders, whether they're academic, business, political leaders, need to show example of ethics for the entire society. So there isn't probably a technology that hasn't been misused. There are misusers of technology. So it's us as leaders to continue to remind ourselves that these are all things that we have to be conscious about and lead wherever we are able to lead about following ethics.
So I think also it's discipline specific. For example, we work with a lot of human participants, and for that we have to take ethics course. It's part of the requirement, so I think it's discipline specific too.
Okay, do we have some more questions from our crowd? Quiet group for a minute. Oh yeah, please. Oh wait, where's the?
I was wondering if you guys had any specific influencers while choosing a graduate program or postdoctoral program that wasn't just program related.
I can speak for myself in that I largely chose the programs that I did because I was able to get a spot in them. And there's a lot of serendipity that happens. I think for me particularly, there was a lot of serendipity in my path, and I was open to a lot of different opportunities, and I tried to, rely on my mentors to grow my network and to just find what spots are available, because it is really, I think, patchy who's got programs, who's got space, who's got money to support students as you go through, and it's really hard to see the future and to map out the direction you want to go. I think it's nicer to have ideas and then to try to fit your plan into those ideas as you go forward.
I think, again, having mentors is important. It's like there'll be a lot of opportunities. So, for example, I did my Ph.D. in microbiology, but again, it's more biochemistry involved, whereas my postdoc is totally on a different aspect. And when I came back, again, it's a different aspect. So it depends on opportunities and mentorship too.
Okay, good.
I think it's also your friends. Like, look at what they're doing and work together. You're not in this by yourself. At least when I was an undergrad, at some point we would all get together and check our assignments together. And what are you doing next year? That's how I met my future wife. Was here at University of my now wife at University of Manitoba. Unless there's another one, maybe. But also my mentors. And I agree with the previous speaker that you go for the best spot that you can get. Try and maintain a level. Also, when I was going from graduate school to postdoctoral fellowship, I was going from MIT, and I was trying to decide between Caltech and somewhere else, and I don't even remember where, but my boss said, you got to maintain that level. Try to keep it that highest level that you can for as long as you can, and that was very good advice.
More questions? How about over there somewhere? Anybody have a question? I'll have to create one of my own then. I'll dig into my little list here. So how do you think your undergraduate curriculum prepared you for where you are today? And if it didn't, in some way, what was missing?
It made everything a piece of cake, let me tell you. The physics program that they used to have here, it was insane. It was after second year, all physics courses. Third year, all physics courses, one math course. Fourth year, all physics courses. So, and no options. for it to take anything else. And so when I finished that, and then going to graduate school after that, it was so easy. It was like, yeah, this is like a break, actually, being in graduate school. And it kept getting easier and easier after that. So for me, it was really some of these things you're going to have to do as an undergraduate. That's going to be the hardest time in your life, and just stick with it, and it gets easier. Trust me.
In honors chemistry, it was the same, maybe not as hard as physics, but we had 40 hours of classes a week, plus studying. So it was compared to some others that I hear, it was pretty heavy, which was a good training ground. We had very good professors. One of my, shared earlier, one of my favorites, there are a lot of good professors, but Ted Schaefer, NMR professor, and so the casual interaction we had as a small class, we were 31 to start, 20 graduated after 4 years. And he would say such things as, the most important development in the last century has been washing machine and refrigerator. Okay, why? Well, it changed the lifestyle for women, wives. And one of the most significant changes, so it enabled more equity between men and women in terms of jobs and careers, when you think about it. So those are the kind of discussions we had in the department, which were really, I think, very fulfilling.
I have very fond memories of studying here, because I was originally math physics, way before you, though. It was still a heavy program, really heavy. But we did have, as I said, the one elective that I was allowed, which was statistics. And then I was crazy enough to go overload and take actuarial science. But I fell in love with statistics, and the department here, it was the first department of statistics in Canada. It was fantastic. I got a foundation from that department that has served me so well, but I was a mathematical statistician, the most mathematical of the statisticians. When I went on to my Ph.D. at the University of Alberta, it was under the Department of Statistics, which came out of mathematics, and again, I was a mathematical statistician, not an applied one. And my foundation in the theory was wonderful, but it was I also got from here the foundation in applied statistics as well. And then when 2 weeks after I defended my PhD, I ended up at Carleton University, and they wanted me to teach applied statistics using computers. They didn't have any. So I walk in and I where's the computers? Because I had to do some computer simulation to do my PhD in mathematical statistics. So I thought, oh, I can do this. I wasn't afraid, because I really got such great foundation from the department here. My PhD was a piece of cake, really. Then I fell in love with applied stats, because we opened a consulting center, the Statistical Consulting Center at Carleton. And I was working on all sorts of problems, and I felt really comfortable doing so because I had experimental design, I had survey sampling, I had parametric and non-parametric statistics. I was really comfortable in every field, and it just grew from there. I have to thank one of the professors, who was Alan Donner. At that time, he was teaching me a course in experimental design, which just opened my eyes to the power of statistics, to understand what was going on in an experiment. Alan went on to go, when he was teaching me, he was master's, he went on to do a PhD at Harvard, and he's been head of biostatistics at University of Western Ontario for many, many years. He was wonderful. The other professor I had was John Rao, J&K Rao, and anybody in statistics knows that John Rao is sort of the world leader, as far as I'm concerned, in survey sampling. He ended up as my colleague at Carleton University, and we're still doing work jointly with Statistics Canada. We're having a lot of fun doing things there, but the foundation was wonderful from here. I can't say enough.
Maybe I'll just echo that praise for undergraduate education at the University of Manitoba in biology as well. It wasn't until that I got to my PhD in the United States that I realized that my foundational education at the undergraduate level far exceeded what my colleagues were coming in with, and I think it really helped me stand out as a doctoral student and as a postdoc, that I had more general knowledge, and that enabled me to pursue more diverse opportunities. I was able to switch model systems 2 different times and to learn new techniques and to start to really build new molecular tools and to start to bring data sciences into my work as well. And all of that is because I had such a great general foundation that was really strong as an undergrad.
So in terms of what it prepared me for, certainly like laying the foundation of computer science was tremendous, and getting comfortable with just learning things and learning things rapidly, I think, is probably the most important thing. My career path took me towards simulating physics for movies and things like this, and I didn't at all take any. I took maybe one first-year course in physics, and the basis that I had in understanding how to learn was what carried me through my Ph.D., where I had to pick up material from fluid mechanics and applied mathematics and all these other sort of adjacent fields to computer science, which, although they weren't part of my computer science training, I had the ability to sort of go out into those fields and take from them the things that I needed to learn. The other thing specific to Manitoba was the great co-op program in the computer science, because I did 3 different co-ops, and one of them was the foundation of everything I've done in the 15 or 20 years since. And so those opportunities were incredible.
Okay, students or faculty or families, any more questions for our alumni? I'm sure you have a few more. Yes, please.
That's easy for you. So at any time in either your master's program, your PhD program, or even now today, since you're all in very highly competitive fields, so there's a lot of stress that goes on, I'm wondering if you can share any ideas, techniques, practices, or routines you did or continue to do to ensure you keep your mental health. Because I'm pretty sure that's important for everyone, and I think we could all use a couple extra ideas every now and then.
Okay, I don't have a great success, example or suggestion for meditation, but the one thing that I will say and would want folks to hear who are thinking about going into sciences is that it can be competitive. If you're doing independent research, you're basically spending your career coming up with ideas and then hoping that your peers don't trample on them too much. But those things are inevitabilities, and so there's a lot of things. There is a lot of stress that can come with it, and it's a long road. You have to love it. On some level, it's not worth it if you don't find something about this job that you love. I get to work with amazing animals. I get to travel all over. I get to see them in their natural habitats. I get to learn about them in the lab as well, and that inspires me, and I love my job. If I didn't, it would not be. I would not recommend it to other folks.
And I was going to say that similar. You have to enjoy it, because there will be challenges. You're competitive. One of the other things that I've talked to others about, and I was taught by my mentor, Bruce Chown, who was in Winnipeg, that we can do anything anybody else can do. So having the confidence that you can do it is important in terms of training, i.e. The background. Secondly, and thirdly, there will be challenges, failures, mistakes. And the ability to understand though there will be those, and that's not a negative. Often we say in our research that we learn more from the experiments that didn't work than we learn from ones that happened to work. And that's life learning. There are challenges and how you deal with those challenges, and you have to have the ability and enjoyment to go through those mistakes.
I would say balance in your life is also important, right? There's certainly periods of your life where you have to work hard to achieve a certain goal, but it's also important to maintain those other elements of your life that kind of, are enjoyable and are a nice break to get away from, whatever thing happens to be stressing you out at the time. Also, like leaning on friends and family, right? Maintaining those relationships. Those are the things that it's, will be around regardless of if your experiment happens to go right or if your code crashes or whatever else is tripping you up that day, right? For me also, like exercise and fitness was something I was really into. I was on the track team here at Manitoba, and I continue to run sort of recreationally in my spare time since then, and I found that sort of like, regulates my emotions a little bit. Yeah, for better or for worse. Yeah, I think that's all I had to say about that.
So 2 things I can say: self-motivation and passion. Those are the things I think that drive. So without those 2, it's tough.
I'm a horrible person to answer this question. Because I always say to my students, bring the stress, maximum stress. I want it. So my true answer, though, is I think I agree that the hobbies and extracurricular activities for me. One of the questions they asked us, at least they asked me when they were putting me forward for this award, was if you could be doing some other job, what would you be doing, do you think? And I gave 3 answers. One was computer scientist. Second one was professional curler. And then the third one was musician. And so those are my hobbies, I realized. So that's what I do in my spare time, and it's important to take the time.
I was just going to say one more thing, which is, I said balance is important. I think everything in moderation, including moderation, right? So every once in a while, you do have to kind of go above and beyond what maybe your peers are doing, and then other times you need to chill out and, relax. And so, just being able to recognize when you need to do one and when you need to do the other in order to successfully make it through your career with your head on straight.
I'm not sure I've got balance. But I love what I do. I will be working crazy hours, sometimes all-nighters, even now. But there's times when I'll take a break. I have lots of hobbies. I have a wonderful family that comes before anything. And I can't believe I'm being paid to do something I love. I'd be doing this anyway. But it's gotten crazy in this last year in particular, as my husband and my daughter will tell anybody. I've just never seen the demand on my time like this. When I was a student, 50 years ago, I graduated here for my first degree. We had classes 6 days a week. When I ended up teaching at the University of Winnipeg as my first job as a professor, I had 17 lecture hours a week, so that trained me to work hard. And when you love it, you understand that there's times when you're going to be working really hard and you're under a lot of stress, but it's fun. And there are other times when you just take off. And frankly, I've got a place in Antigua.
And maybe I'll just close it out by saying that I've just remembered that I played rugby in graduate school. It was very helpful.
Okay, do we have any more questions for our wonderful alumni? Yeah, please. Thank you.
Hi, I just wanted to ask, what was the major hurdle in transferring your scientific training and knowledge into successful business or something of the sort?
Well, I think it's the same as any other. When I transferred from being a chemist or biochemist to production, I had to learn a lot. And so I was in doing separation and plasma fractionation. I went to every major fractionation plant in the world to see what they were doing and learn. Now, at that time, they were pretty open. There wasn't as much confidentiality. So I knew I had to learn a lot, and I spent a lot of time. Even when I started the process, I knew I didn't know some of the technologies. So I went to 2 professors in faculty of medicine that had certain technologies in their lab, and I went to the professor and said, would you let me work in your lab for 3 months? I'll do whatever you want. I did that to two times to 2 different professors to learn certain aspects which I needed to learn. The hardest lesson I learned in business was, for 20 years I was the head and president of the RH Institute. They were taken over in a hostile takeover by a business person. And until those, prior 20 years, I'd never run into any relationships with Johnson & Johnson, Ortho, Baxter, et cetera, where their word wasn't their bond. And so it's not true for every place. And so that was the hardest lesson, probably.
The hardest one I had was being a woman. My first interview for a job, as I told you, I wasn't supposed to be at university, much less go all the way through to a Ph.D. At the graduation of my first degree, my honors degree, I interviewed with Imperial Oil, and they said I had all the qualifications they needed but one. I guess you can guess up which one that was. So that was a wake-up call for me. It didn't stop me, though, but that was a tough one. The second problem that I've encountered, I think I've kind of gotten past it now, is the fact that because I am very mathematical, a lot of people were afraid that I couldn't explain what was going on in my methodologies. And said, well, you're academic and you're really this mathematical type person, you know, you're not going to make us understand. I think I proved them wrong on that too. But there were those were the 2 barriers. And I think the first one was the gender one, that was the biggest one.
Yes, please, wait for the, yeah.
So science these days is becoming very interdisciplinary, and I was just wondering, I know that a bunch of you said that you were in very focused programs, but I was just wondering if there were any courses that some of you took that were outside of your discipline, or that you would wish you had taken that could have helped you with moving forward, and what those would be.
Statistics. That is one thing I still like to take. So yeah, there is always a learning curve. I mean, it's never ends, right? So, but nowadays, instead of taking a course, I learn it from my colleagues, collaborate with them, I learn it how they do. So whatever we're doing now, it's interdisciplinary, at least my work. So you need to, it's very tough to learn all those things, right? So you have to learn it from the experts sometimes, but statistics is something, definitely.
Yeah, I would have liked to learn more math and more physics and more engineering, all those kinds of like connected fields to computer science. But also, things outside my field that I didn't really take because I was so focused on trying to get every single computer science, course I could under my belt in undergrad. I didn't, try anything out in language arts or geography or, social science or any of those kind of other areas. I sort of decided, okay, I'm in university, it's going to be everything in this one particular area. And, again, it's good to have a mix of things, I think. You have the whole rest of your life,
Yeah, I'll go on more on that topic, like the rest of your life. Like, I'm an academic, and I just keep learning things. Like, I have to go back sometimes and reteach myself things, and that's important to be able to do that. recently I had to learn how to cool something to above, a few fractions of a degree above absolute zero, and I had to learn how to build the refrigerator that does that. And it was hard, but I figured it out, and now I know how to do that. And so, yeah, anything is, you can always teach yourself something. I wouldn't be very terribly focused on the courses, which this course or that course. It's more like make sure you have the ability to learn, set the groundwork for what you're going to need to know for the future. And it might be, unpredictable. A nuclear physicist like me, we're famous for being afraid of thermodynamics, which is what you really have to understand in order to build a fridge. And now I had to build one, so I had to learn it.
Okay, one more question from the floor. Again, wait, let's see if anyone else, otherwise we'll get you. Anyone else? Sure? This is your chance. Yes, we'll get to you again, don't worry.
Is it hard to get a job that isn't directly related to your field? Like, I'm in math and physics right now. If I wanted to go into maybe computer science as it gets more popular and stuff, even if I'm able to learn those things, would the people hiring me not take me seriously without a degree in computer science?
I guess I should answer that as a computer scientist. I think computer science is still a field where if you can just prove you have the goods, then you can, be employable. It's just a matter of showing that you can, achieve whatever it is you need for that particular job. Yeah, I mean, I don't know, there's various types of licensing coming in this kind of stuff. And so if you need to learn a particular tool or get licensing in that particular, technique, you can certainly do that. But I think at the end of the day, if you can get stuff done, that's what companies care about.
This is what I meant by basic aggressiveness. You have to go out there and sell yourself and be that person that it is that they need you to be. My brother, who's now a lawyer, used to say, you just go into the interview and you just tell any lie that you have to tell to get the job, okay? Because you can do it. You have that ability to learn as like a math student or science student in general. And it really is kind of true. There's going to be some on-the-job training, and you just have to market yourself the right way. I can also say a few jobs that I considered. So as I finished my postdoc and I was looking for a faculty position, that's a very hard transition, and that's a possible bailing out point. I interviewed at a company that was building. These are all jobs that I was offered and turned down. Okay, so I interviewed at a small accelerator building company. So they built little electron accelerator components to be made into medical accelerators. I was in Long Beach, California. I interviewed at a company that did smart metal research. It was building components for NASA. And then I interviewed at a hospital and was offered a medical physics position. And all of those were really easy to get. And so, I got offered those jobs, so it must be easy.
So the last question with our major question answer. Asker, I'm sorry.
So obviously, once we graduate with our degrees, we're going to have a variety of technical skills at our disposal. But obviously, we also need a set of soft skills in order to be successful in our careers. So what soft skills do you value most in an advanced graduate that they would graduate with, as well as if you have any recommended ways to go about developing those skills in perhaps non-obvious ways, like developing our speaking skills might give more talks, but that's not something you might be able to do every week. So are there any things we can incorporate into our graduate curriculum that we can use to build those skills that will make us as marketable as possible once we do graduate.
In our business, one of the most attractive soft skills for me is teamwork. The hardest thing is, and I've seen this in other companies, Sharon Plow, VP of Research, at one time told me, Cecil Pickett, that he took on the job of managing some billions of dollars of research. And the hardest thing he had to do is get the people to work together. So they all want to get ahead. But so he actually had to build a floor where people would go for lunch and pay for the lunch and so on to get people to talk to each other. So for me, in our work, working to team, and we have a sales team, and every day at 4 o'clock we get a huddle. Everybody comes together and shares and talks. And the challenge where we've had most challenges is when people don't want to work with somebody else, and it breaks down the team effort. You're stronger as a team.
It's funny to think that you would have to force a bunch of graduate students to go to lunch with each other, but you do. I had to do a very similar thing, and I was on sabbatical last year in Vancouver, and I had to like commandeer a picnic table, and then I would force all of my graduate students to eat lunch at that picnic table together every day. And yeah, it really helped the team environment. And yeah, so teamwork is important. Communication is also important, not just in the sense that you mentioned about giving public speaking opportunities or something like that, but also just, yeah, in the team aspect of it. So being able to tell what you did to somebody else. It's amazing that how hard that can be for someone, but it's very important.
Okay, well, this has been fantastic, I think. Very good questions. Thank you, students and crowd, and thank you to our honored alumni for answering.